Hey scientific people, how are you? So I'm going to discuss today ray optics problem number 9.34 NCERT textbook CBSE physics ray optics. Now here they are asking that a small telescope has objective which face towards the object. Two lenses are there in a telescope. This is objective which is facing the object. This is the eyepiece where the eye is supposed to be there to see the image. The focal length of this objective is 140 centimeter and the focal length of eyepiece is 5 centimeters, correct? And what are the magnifying powers in both the cases? Now, what do you mean by both the cases? This means that the rays are going to come from infinity. I'm not going to draw the ray diagrams over here, but I'll just try to explain you the concept. So the rays from infinity will come like this. So object is at infinity, and now the image for this particular lens, the object for this lens is at infinity, and the image will be formed at the focus of objective. That means over here, this point is the focus of the objective, and the focus of the eyepiece and focus of the objective, they both are coinciding in this particular case, as we know that eyepiece can be slided over like this. Now if this is the image for this, then this will behave as the object for this lens. Now since this object is on the focus of the eyepiece, then the final image which will be seen by the observer will be at infinity, because if the object is at focus, the final image is at infinity. So when final image is at infinity, it is referred as normal adjustment. Final image at infinity, correct? And under this situation, the magnifying power of a telescope is given by FO upon FE. So this is very easy. This is 140 upon this is 5, and centimeter getting cancelled. So this is simply a ratio, that is 28, which means that the final image formed by the final angle formed by the image at the eye is 28 times more than the angle formed by the rays directly at the eye. So you can consider that these rays may be directly falling on the eyes, because this distance does not matter, because as the rays are coming from infinity. So the rays may fall over here or the rays may directly fall over here. It does not matter. It makes some angle with respect to eye, whereas the final image makes some angle with respect to eye. That angle is 28 times more than this particular angle formed by the direct rays over here. Now in the other case, as you can see that the focus of the objective is here and the focus of the eyepiece is towards the left hand side. Now again, since the object is at infinity like this, the image will be formed at the focus of the objective. Now this image will behave as the object for this, and this lens is arranged in such a way that the final image is formed, say here. And we know that since the image is formed, since this is the object which is between the optical center and the focal length, the final image will be enlarged on the same side of the lens and virtual. Now this is going to make some angle over here. This angle would be more than this angle, and that is what is called magnifying power, correct? So this is the final image, and this final image is formed at 25 centimeters from the eyepiece or the eye, because both of them, they are considered as the same, because eye is very near to the eyepiece. So here final image is at D. That is what is the second part at distinct vision, 25 centimeters. For that the formula is this one. So if you substitute the value, you will get 140 upon 5, then 1 plus 5 upon 25, and if you solve this, you get this as 33.6. So no formula, sorry, no unit, because this is the ratio of the actually angles.